Hello, everyone. Welcome to the labeling and highlighting talk. My name is Min Champagne, and I am a visualization developer here in Wolfram. It has been more than a decade that I work for the Wolfram now. In this talk, it will be two parts. The first part, we will look at automatic labeling and highlighting. So I have been giving labeling talk for a few years now, and the highlighting we introduced in 13.1, which is about an year and a half ago. Um, and here we will, take a like overview look at them. I think so in this presentation, I want to focus. I hope I can spend more time on the second part, which is the clinic with curated questions. For the people who are not familiar with labeling or highlighting, so I'm referring to like this automatic behavior, for example, and this is a good representative of the automatic labeling. The being the point that the label is not trying to um, conflict with each other and is not covering up the features and the highlighting. So here I use the static highlighting, but what I refer to is the mouse behavior that is live. When you get close to the curve. So let's just jump in. Um, so the first part, I want to talk about the automations. We have done a lot of automations on the labels um, in terms of the layout, and the main point is that they are not, they are not you know, conflicting with each other. And for that, we have made a lot of effort. And for example, we optimize the distance between the labels. So I hope that this will become an atlas for you, that you can just come back to the notebook and find something that you will need. This is the plot labels for a lot of the visualizations functions. It has this option plot labels that it is different from the plot label, which is just a label for the plot. And then, for example, in this timeline plot, it is a vertical layout, and the labels is aligned in a way that they don't run into each other. So it's in the pie chart. And for the stacking, this is the same timeline plot, but with a horizontal layout. You see the labels are stacked together. Using the same stacking algorithm, we do this for the bar chart. And then we have the feature collision avoidance algorithm, and this is the point features. We have different types of strategies. One is just the label. The other one is the call out. The call out is more, it's clearer that where you're pointing the labels, um, where the points the label is associated with. But labeled without the call out line, the leader lines, save you some space. Um, well, the bubbles is a extension of the points. So we made the same algorithm work with the bubble chart. Another feature that we have done this is for the curves, for the lines. So this is the same plot with different frequency on the on the sine curve, and this is the same specification of call out. I want my call out at the location of pi, and then you see that how the labels is adjusting itself, so it doesn't run into the curve. Okay, and the type of automatic highlighting. Um, so we have some preset effects. It could be just as simple as style, any style. Red, blue, bold, different thickness of the line, different size of the point. Any style that you can use, even with the drop shadow. That's the new styling functions in the 14.1, I think. And we have the different preset names: bold, drop line, X slice, Y slice. This is a preset effects, and underneath these presets, they are components, and this is from documentation. So we have three big components. They are point, line, and label. For the point, there are different type of the points that you can specify. And for the line, there are different type of lines, and the label, different kind of labels. You can pick and choose from these three groups to form your own highlighting. Um, so here I'm just going to go through with these four presets. The first one is the ball, which is, you know, effectively indicated point with XY label. So this is the, by the way, this is the default behavior if you just do a visualization plot. And so here is essentially doing the same thing as this. Um, as you can see, the drop line is the point plus XY drop lines and labels. So that gives you this. So I mean, here just to prove that they are actually the same thing. And then we have the X slice, which draws a vertical line across the plot, and when you move around, and they will give you labels. These labels using the same algorithm of the feature collision avoidance for the points. So you see that they are not, the labels is moving around in real time, and then they will not across each other. And so this is essentially these three components. And you have the horizontal slice, which is similar. So when there is no place that they can put the labels so that they don't collide to each other, they still uh, place the labels, and then the collision is inevitable, but you still get the labels. So that's the automatic highlighting. So the second part is that I want to go through with a list of questions that the Viz team usually got asked internally and externally. Some of these questions are also from the Stack Exchange that I found that very useful. So first one that that people ask is that why is I specified call out in 2 points here, but why doesn't both of them shown? Well, so it happens to be that the callout is specified in the first point here is this one that is kind of cornered by other 2 points. If you can see my tooltip, that is the callout that didn't get shown, but placed in the tooltip. And then by default, so the reason is doesn't get shown is because it doesn't want to show and so that it will cover other two other points. The other thing is that by default, it doesn't place the label outside of the plot range because it will get clipped. So there's really no location that the label can be placed without being obscured. So first solution is that you can just extend a plot range padding so that it has more room, and then you will see the label. Or the same thing but different option, you just change the plot range, give you the same result. Or if you don't want to do all of them, you can specify label visibility, go to all, and this will force this call out to show. And but you see that this leader is covering up one of the points. Well, but you have options there. Sometimes I would recommend if the plot range is if um, it is okay to increase the plot range, I would recommend choosing the plot range solution 2. And why aren't all my labels shown even with bigger image size? So I hope I can demonstrate this in this presentation environment. So a lot of time people evaluate the example like this, and they see that there are some points that don't have the labels they want. So they increase the image size. And first thing you notice is that there are no more labels shown. It is because that increasing the graphic size through this way doesn't rerun the algorithm. So the labels will not be regenerated. But then after this, people reevaluate the input, and now it is this big and it's reevaluated. But why doesn't the label show? Well, that's because the output graphics has a cached image size. So internally for the kernel, what kernel knows, the image size is still the small image size that's taken into consideration. But when it's displaced, it is using the cached image size in the output cell. So what you really should do is explicitly set image size. Okay, then you will get um, more labels. But if you look closely, you might still find one or two labels. Oh, not in this example. That sometimes, even in this situation, it's still possible that some of the points is still cornered by other points that you can't see the label. So what if like I really want all my labels to be shown, despite of overlapping, for example, like this, you know, and it's I understand it is important in the exploration stage of the data that you want to see all the labels, just to know that what's going on there. Well, first of all, if you specify labeling function, go to call out. So labeling function is a general option that's available for a lot of the data visualizations. So if you specify labeling function, go to call out, that's essentially say that, hey, I really want to see all the labels despite the overlapping. So then you see all of them. But this might not be very useful for your exploration. What you can do even is to increase image size, change the label style, so then you have more labels. Another solution is that you can change the labeling size. So for example, so this is another general option that's available for all the visualization functions supports labeling. You can see that labeling size go to certain value. In this case, I choose 100, and majority of the words here is less than that size, but there are occasionally some longer words, and they will get the ellipses, so that some saved some space. So that's another example. And this labeling size is particularly useful if your labels images, and you can see. So to even give you tool tips to show a bigger version of them, right? Okay. So another question that get asked is that, is it possible to force labels to appear only in certain positions? But you know, so I'm still talking about automatic labeling. I mean, certainly that you can say call out words all goes to the, like left or top, this. But this is not automation. This is just, you specify the locations for the labels. What I really meant is that, what if I still want it to have automatic behavior, but it's just that I want to limit the choices of the labels positions. By default, there are 8 positions that a label can be around a point. That will be the diagonals of the points, the 4 corners, the top right, top left, bottom right, and then you have the right, top, bottom right, left, right, the 4 positions. So in total, 8 positions will be used. But I think in the 14.1 release, we sneaked in this method option, which I will make sure that this get documented. And this is an option in the callout, and you can say that, hey, I really, do your automatic collision avoidance algorithm, but what I really want is just like, instead of the 8 choices, I only want you to choose between, say, left and right. Say, then you will only choose left and right, left or right for the positions. Okay. So another example here is that, so this is a fine example. So, the labels is trying to avoid points and successfully avoid the blue points here. But I really, it would be really nice if this label just all on the left-hand side, so it doesn't, block the trend. Then you can do this. These, we only allows the positions for the labels to be on the top left, the left, and bottom left, and then you have that. Okay. Um, well, this is another question that I saw on the Stack Exchange, that this is a plot, fine, and here I add a call out, but suddenly I notice a slight difference on the plot range. Since this is 1.2 on the top, but here is 1.1, around 1.1. So why is there this difference in the plot range in the plot range? So the reason is that adding a call out changes the automatic plot range padding for just for it's sometimes the call out is pushing it's close to the top, so that will force if we don't have enough padding, then the call out can be clipped. So we added a more padding because of that. Um, we might, revisit this behavior so that, it's not doing something unnecessary. But in the meantime, what you can do is just set the plot range padding explicitly, and then, to avoid the problem. So here, plot range padding, it's explicitly set. Another question I saw on the exchange, which is why, how can I change the leader size of my call out? For example, I put the call out sign X at pi over 2, and I said the leader size go to 20. But no matter how I change this number, it doesn't actually change. And also, why isn't my label pointing exactly at pi over 2? Well, so the thing is that the third argument of the callout is the label position, and the fourth argument is the leader position. So here you actually specify the label position and the pi over 2 on the x, and the y is automatically decided. But the leader position, it's automatic. So the algorithm is going to run its course and find an attachment point. It doesn't really know that there's something special about x equal to pi over 2 of the curve. So, and because you specified the label position, and that will fix the leader size. So this is actually a conflicting with the specification. It's over specified. So leader size um, is getting ignored. So what you can do is that instead of set the third argument, set the fourth argument, saying that I want the leader to attach at pi over 2 of the feature, and let label to flow automatically. So it finds a very nice position to put it. And now if you say leader size go to 50, then it will extend the leader size. Okay. So that's some curated questions I found that I want to share with you. The next part is the highlighting. So this is another question that we get asked a lot. So I have a plot, which is sine x, and now I'm putting a tooltip on the plot. But suddenly, my plot doesn't have the highlighting anymore. Instead, I have the tooltip. Well, the thing is that there are certain wrappers, they use the same mouse gestures um, as the plot highlighting. And in that situation, the automatic plot highlighting get obscured by the wrapper. Okay, so what you can do is that you can set the plot highlighting explicitly to override the wrapper. In this case, I set it to ball instead of automatic. So I set it to ball, and then you have the ball. But yes, because they share the same mouse gesture, now you don't see the tooltip because my um, my mouse is now actually on top of this highlighted point. It is not on the curve anymore. Well, so what you can do is that you can actually change these highlighting method to XY label only. You don't want to see the ball because the ball is obscuring the curve. Then, sorry, that's not what I meant. Then you have still have the label, and then now you also have the tooltip, right? Um, so this is very popular question, which is, so this is nice that you have XY coordinates, but is it possible that I add some content or, some different formatting um, for the labels? Well, the solution is yes, you can do it, and it is using this um, parameter for the components. That's called the labeling function. If you see the documentation for the plot highlighting, it says that the labels takes parameters from callout. So all the callout options, you can use those options for the labels. And that's how you will actually change the appearance of this label as well. But we'll save it for later, but we are now just talking about the labeling function. So this labeling function is another parameter you can change. And for example, it's currently providing you the labels. And this labels is actually formatted labels. So then you can do um, your own formatting for the information. And then you can have the XY values. Then you might ask that, so that's nice, but for example, when I goes to 3 pi over 2, there are a few values share the same y values, but they are not accurate enough. Can I see more digits in the label? Well, so the reason that you may ask that question is because that these labels are formatted strings of the coordinates. It doesn't really know that it is about sine x and how many digits you want. So the workaround of that is that you unformat that string by using two expression, and then you can construct your own. So here I unformatted the string by two expressions with two expressions divided by pi, and I put the pi back as the unit, and then I can have this. Now you have all the digits, the precisions by default. Well, then you say that's very nice of you, let's do that, but that's too many digits. I mean, I don't need that many digits. Fine. Well, you can just actually you can just use number form, which is actually by default we are using underneath, say 3 digits or 4 digits. Then you have a fixed digits there. Okay. Um, but that's very nice that you can do this formation on the plot highlighting. But what if I have two curves? And now the problem is that the first curve is sine, second curve is cosine. But now the second curve has the wrong information. How do I specify the labeling functions for each curve? Well, so the problem is that plot highlighting is an option that applies to the overall highlighting to every curve. So to be able to specify different labeling function for each curve, then you use wrapper highlighted. Then for each curve, you can specify its own labeling function. Now then you can have this. Right. All right. The last question is from Brett's talk yesterday. So someone asked that can I put, so for the X slice, so this was a plot Brett was showing yesterday. making the point that the labels is avoiding each other. The labels are avoiding each others from colliding into each other. So the question was asked about, is it possible to put the one label always on the left, the other always on the right? And Brett said that, it's not possible because call out is using, um, traditionally we use call out, you have to specify the positions for the call out. And that is true. We do not have a mechanism, we do not have a syntax for you to specify where the labels should be. So it's just floating automatically. But with the method option that we just discussed, you can actually put that method options in the label for the parameters, and you can work around it by only specify one possible location for the allowed positions. Now, one curve is only allowed to put on the left, the other is only allowed to put on the right. So then you have what you want. So I hope the person who asked that question saw this, and hopefully this will be useful for you. So that will conclude my talk. I'm going to take a look to see if I got any questions. So the question is asked, will this notebook be shared? Yes, it will be. Is this improved label placement also available in graph display? It is currently not, but we have been discussing how to have labels for the graph, and I believe that this will be something down the road. Is it possible to increase the size of a plot so the more or all of the labels can be displayed with calculations? Um, well, so the thing is that you can increase the image size, but it doesn't guarantee that there will be no collisions. I mean, so like, right, so let's take a look at this. Right. By increasing the geometry of the graphics, which means the plot range, aspect ratio, image size, plot range padding. So all the options that affected the real estate of the graphics uh, will be taken into consideration for the labeling algorithm. But that still doesn't guarantee you that all of the points will have an labels not colliding with anything. It's very possible you have a point surrounded by you know many other points, and there's just no positions that the label can be placed without collision. um, but but so so the answer is no, there's no guarantee in that situation. But what I'm trying to say is that you can increase. So a lot of people would say that, wait, I think this algorithm might be a little bit too aggressive. What I would suggest is that you can increase the image size and then you can shrink it back a little bit, and to find that at what extent this is acceptable for you. So that's another possible solution. I hope I answered your question. Cool. Is it possible to have mixed styling with X, Y axis labels? Um, if you meant that in the highlighting, like, in the XY label, you want the X styling to be different than the Y. Um, also, I was trying this. So because this is string, but they are in the list. Um, so if you do select this, so then you can have this. So yes, the answer is yes. You can write styling functions apply to each of the right. So you could do right. Then you have right, right. So then this will give you two of them, and then you can wrap style around of each label. Then you have two different styles. So yes. All right, thank you so much. I hope this is useful for you. And please join our visualization office hour today at 2 o'clock. And me and my colleagues will be there. Thank you.